The trigonometric functions cosine and sine are functions that oscillate over time, as shown in these two graphs here. And a helpful way to understand how these functions are actually defined is to tie them to the unit circle. A unit circle is simply a circle of radius 1. So if we lay down our x and y coordinate axes again, so here's our x-axis and our y-axis, let's draw a unit circle on there. So it's a circle centered at the origin, and it's going to pass through these points on the x and y axes. So it's going to look something like that. It's called a unit circle because the radius is 1. So to make that a little clearer, let's draw this to be our radius. There's some angle theta, and that radius, that distance there, is equal to 1. Now for any particular angle theta, we can ask what the coordinates of that point on the unit circle are. So in other words, we can ask what the x-coordinate is of that point, and we can ask what the y-coordinate of that point is. Now one way to think about the definition of cosine is it is the x-coordinate of that point. So the x-coordinate of that point is equal to the cosine of that angle. And likewise, one way to think about the sine is to recognize that the y-coordinate of that point is equal to the sine of that angle. That's one way to understand the definition of sine and cosine. So as this angle theta increases and it goes from 0 through to 2 pi through to 4 pi over and over again as we keep going around and around this circle, you can see that the x-coordinate will oscillate between 1 and minus 1, and the y-coordinate will oscillate between 1 and minus 1 as well. And the cosine function and the sine function tell us exactly how that coordinate of x and that coordinate of y oscillate as the angle theta increases. A slightly more general way to think about this relationship is to draw a circle where now the radius of the circle, instead of being 1, the radius is equal to r. So I'm going to draw a line like this again, and there's my angle theta, but now this distance is equal to r. And again, I can ask the same question. What is the coordinate x of this point here? And what is this coordinate y of that point? And in this slightly more general setting, the x-coordinate is equal to r times the cosine of theta, and the y-coordinate is equal to r times the sine of theta. So you can see the relationship between these two cases here. In the top case, where we're dealing with a unit circle, basically the radius is set equal to 1, and so you can imagine that there's actually a coefficient sitting out front of each of these trigonometric functions, cosine and sine here, but that coefficient is equal to 1. Now we can also consider the relationship between these trigonometric functions and right-angled triangles. So to do that, let's again write down this slightly more general form where we're using a circle here that has radius r. Now let's consider the case where this angle theta is acute. Theta is an acute angle. In this case, we're going to take this little triangle and we're just going to look at it in a slightly blown up form. So here it is. Here's this triangle. There's theta. This distance is r. This distance is y. And this distance is x on our diagram here. Now you probably recall from your study of trigonometric functions in high school that we can write the sine of this angle theta in terms of these quantities on the edges of this triangle. In particular, the sine of the angle theta is equal to the opposite over the hypotenuse. That's the opposite over the hypotenuse. And therefore, y is equal to r sine theta, as we saw on the previous slide. Likewise, you probably recall that you can write the cosine of that angle theta as the adjacent over the hypotenuse. That's the adjacent over the hypotenuse. And of course that means that x is equal to r cos theta, as we saw on the previous sign. So there are two formulas that relate the sine and cosine functions to x and y again, this time through a right-angled triangle, and this interpretation is fine so long as the angle theta is an acute angle.